So stop mode. Idle mode is the next mode. And then in that mode, the vessel might be just loitering out in the harbor waiting for the next vessel or next job to come along. In that mode, you have propulsion enabled, so that's the big difference between stop, and of course the shore power is not connected. So here you typically be running off batteries with very low load on the vessel, so you're in zero emission mode. You might only have some air conditioning on. The neat thing about idle mode is that often when you're sitting there with the generator running, there's other things that have to be running, like cooling water pumps, ventilation fans, other things in the engine room that also consume power that are running just to support the running of the diesel. So when you shut that down, you actually lower your hotel load as well. So in this mode, you might sit there for 3 or 4 hours running off of batteries until the next job comes along and you have to go somewhere. In this mode, if you need to use propulsion, it's available. So if they want to reposition the vessel or move it out of the way a little bit, that's available running on batteries. So you don't have to start up a generator just to make a small adjustment to vessel position. It's really cool to be able to run around with no engines running, but it's not really it's intended to be used. Okay, the other mode is transit 1. In that mode, you're capitalizing on that one area that was the 10 to 15% of the time, or 10 to 15% power, 55 to 60 or 50 to 55% of the time of operation. And that's moving from one job to the next job. The harbor speed limit here is 6 knots, and that's typical for a lot of harbors. So it only takes about 300 kilowatts to move a vessel the size of a tugboat through the water at 6 knots. So that's what that size generator is. That's a 350 kilowatt generator. It's operating right at its sweet point as far as power goes when it's moving that vessel along at 6 knots. So this guy's closed up, supplying the DC bus, and then these 2 motors are supplied off of the variable frequency drives. Everything else is shut down. If there's any overhead in this guy where he can provide additional energy to the batteries and they need to be charged, and the batteries can be topped up at a high rate of efficiency because this guy's up over 60 or 70%. And that's how these vessels run around the harbor most of the time. So they're in their most efficient mode of operation because this diesel's up in the 70 to 85% area of operation. Transit 2, if the vessel's outside the harbor, it needs to go somewhere faster, and sometimes operations dictate that. There is a way of doubling the power available to the shaft line, which gets you about 50% more speed. So the vessel's moving at 6 knots, 300 kilowatts, it's actually going to take another 300 to go 3 more knots. So to go 9 knots, or 8.5 knots, it's going to take over 600 kilowatts. But that's accommodated in this design. That's still a lot more efficient than running these 2 engines at 10% load. 10 or 15% load. So again, it's about configuring the plant around that duty cycle. In assist mode, that's when you're assisting another vessel. The tugboat was designed for to be available to provide full power to move these boats around the harbor safely. And that's what you've got, basically the auxiliary generators on, you've got the main engines clutched in. Everything is available to support the propulsion side of the vessel operation. And there is a lot of layers of redundancy here as well. In the past, if an engine were to fail, a main engine, there would be nothing available to that shaft line. Now when you're in assist mode, if this main engine fails, you still have all this power, 2 generators and batteries to be able to contribute to the MG set and at least help with that shaft line. It won't be full power, but it's better than having a dead shaft when you're trying to maneuver around these tight areas with these large ships. So that talks about the efficiencies quite a bit. Well, I'll get one more slide here. I'll just go through. And we're also talking about any time even when you're in assist, if you want to go back to that conventional mode or non-hybrid, that's always available to the operator. There's one other one that's kind of neat that we like, and that's called single engine configuration. In this mode, we run a main engine through the motor generator. We're running the motor generator as a generator in this mode. It's a variable speed generator, induction generator. That then provides power to support the DC bus. Nothing else is running except this one main engine. So if you're wanting to do a long transit, at say 10 knots or 11 knots, which sometimes these guys do if they're going down to San Diego or something like that. They can just run down on one main engine. This engine will support the vessel service by supplying the DC bus, and it will support the other motor generator. So the diesel is designed around bollard pull, which means that this diesel is going to be matched with the propeller so that at the rated speed for that shaft line, that diesel's at 100%. As soon as the vessel starts to move just a little bit, or the vessel's pushing moves a little bit, then you get inflow into the propeller, and the load requirement to turn that shaft at 1800 RPM or whatever it is drops down significantly. So that means that additional power that's available in that engine that can go through to the DC bus is available for this generator and to support hotel load, charge batteries, whatever's needed. Okay, so we talked about the efficiencies that this provides. The other thing that is really efficient or really significant as far as the system design goes is every time you don't run a diesel, or if you're running around for 15 to 20% of your time on this one diesel as compared to running main engines and a ship service diesel, that's a huge, huge reduction in maintenance costs. Because if you're the difference between overhauling each of these engines every 5 years, say for $250,000 for a total overhaul on the engine, compared to now, if you're reducing the operating time of it to the point where you don't have to overhaul them or do a major overhaul for the whole life of the vessel, this is the difference that they're talking about as far as reduction in maintenance costs. So that's a really significant component of this whole system design that's not really taken into account as far as the business case goes too much. Usually we're talking about reduction of emissions and reduction of fuel. So that's something that's worth noting as well. So I'll go through some slides just on the construction. This is a motor generator set getting installed in the Carol and Dorothy. So it's just being set in place. The shaft line, that's it in place before the shaft line's hooked up. You can see the switchboard. That's also one of the challenges to the Dolphin tugs. The Dolphins are known to be a really compact design, high horsepower, and small and very agile vessels. And the small and agile part means that there's almost no space in the engine room. So it was a real challenge for us to fit this system into the engine room. And one of the other things that we didn't talk about was that often industry, when they're talking about designing around duty cycle, what has happened in the past is that you end up going to a diesel electric plant. If you're talking about an icebreaker, a vessel that has a lot of very high power requirements but doesn't always use that high power, you typically go to a diesel electric. That's pretty expensive, but it also takes up a lot of room.